Welcome. Today we'll evaluate the improper integral of x over 1 plus x squared from negative infinity to positive infinity. Let's first visualize the function we're integrating. Here's the graph of y equals x over 1 plus x squared. Notice a few key properties of this function. First, this is an odd function. It's symmetric about the origin, but reflected. Second, as x approaches infinity or negative infinity, the function approaches zero, creating horizontal asymptotes. Because this is an improper integral over an infinite interval, we'll split it into two parts at x equals 0. For the first integral, from negative infinity to 0, let's make the substitution u equals negative x. When x goes from negative infinity to 0, u will go from infinity to 0. After this substitution, the first integral becomes negative integral from infinity to 0 of u over 1 plus u squared do. Now, combining both integrals, and using the fact that negative integral from infinity to 0 equals integral from 0 to infinity, we get. This makes sense geometrically. Because our function is odd, the area above the x-axis from 0 to infinity exactly cancels with the area below the x-axis from negative infinity to 0. Therefore, the improper integral of x over 1 plus x squared from negative infinity to infinity equals 0. This example illustrates an important principle. When integrating an odd function over a symmetric interval about 0, the result is always 0.